binomial distribution. Let's look at binomial distributions and then the Poisson distributions and their characteristics. Remember the word probability right from the day we defined it. We said it's simply the measurement of chance or measurement of chances. That is probability. But there are several ways of measuring chances. There are several ways. And two of the ways are binomial distributions and Poisson distribution, which are very specific. What are the characteristics or what differentiates binomial distributions from Poisson distributions? For binomial distributions, you always know that there are only two possibilities or two possible outcomes we'll be looking at. That is the outcome of a success or the outcome of a failure. So normally what is done in literature is that the probability of success is always represented by the lowercase p, as you see here. And then the probability of failure is also represented by the lowercase of q. And then the number of trials you do is also represented by the lowercase n. Okay, this P, Q, N, you find it in the binomial formula. And then, of course, I hope you haven't forgotten the symbol we use for random variable. Random variable from last 2 weeks, we've been using the letter X to represent the random variable. But in binomial distributions, instead of using the uppercase X like this, we normally use the lowercase x as you see this way. In essence, these four variables you are seeing, the lowercase p representing the probability of success, the lowercase q representing the probability of failure, the lowercase x representing the random variable, and then the lowercase m representing the number of experiments or number of trials you do. These four, P, Q, X, and N, are used to formulate the binomial distribution formula, which you'll be given in the exam. So there's no need memorizing all the formulas I've given you. I've told you you'll be given a formula sheet that has every formula that you need. So this is the formula. Whenever you want to find the binomial probability distributions, binomial, bi means two. So bi means two possibilities. And the two possibilities are that either you will have success or you will have failure. These are the two possibilities that is making this probability have its name as binomial. Okay. So anytime you are asked to find the binomial probability distribution, this is the key formula you use. And is as you see on your screen, probability of a random variable X going through a number of trials, n is equal to, on the right-hand side, you have n, and then look at this symbol. This symbol you are seeing is called factorial. It's called factorial. So we mentioned this expression as n factorial. Now, the meaning of factorial. Factorial means the number of ways. The number of ways of arranging items. The number of ways arranging items. So, for instance, let me give you an example of factorial and then we come back to the formula. If I give you these numbers, 1, 2, and 3, and I ask you, how many ways can you arrange these numbers? Now, this is what you can do. 1, 2, 3, you can arrange it the same way, 1, 2, 3, or you can decide that 3 should come and lead. So you can make it, you can arrange it as 3, 1, 2. Or you can also arrange it this way, 3, instead of the 1, you bring 2 first, followed by 1. It's the same item, but you are changing the arrangement. You can also change it again and make it 2, 3, 1. Or you can change it again and make it 2, 1, 3. Same items. You are just changing their positions. Or you can arrange it as 1, 3, 2. So look at the arrangements we've made. This is the first one. This is the second one. This is third. This is fourth. This is fifth. And this is sixth. In other words, if you are giving the numbers 1, 2, and 3, you can rearrange them in 6 different ways. That's what we have just done. We have arranged 1, 2, 3 in 6 different ways. Okay. When you do that in maths, we call it factorial. Factorial. And that was why I gave you that definition, that the number of ways of arranging items. So when you are asked that in how many ways can you arrange 1, 2, 3? All you need to write is you write the number of items, 3. When you count them, you have 1, 2, 3. And then you put the symbol at the back. So you are telling me that the number of ways we can arrange 1, 2, 3 is 3 factorial. When you press this on your calculator, 3 factorial, your calculator will give you an answer of 6, telling you that 1, 2, 3 can be arranged in 6 different ways. 6 different ways. So this is how the calculator gets the 6 for you. Anytime the calculator gets 3 factorial inputted, what you are simply telling the calculator is that it should keep going back till it gets to 1. So from 3, you multiply it by 2, because from 3 you go to 2, and then you go to 1. The moment you get to 1, this factorial sign goes away. That's the only time it will go away, because you have to reduce the number here to 1 before it goes away. So 3 factorial means 3 times 2 times 1, which will give you 6. Meaning that when you have 3 items and you are rearranging them, you will have this as you see here. Now, in the same way, if I write 2 factorial, it means the answer will be 2 times 1, which is 2. Meaning, how many ways can you arrange 2 items? So if I have 2 items like 3 and 4, how many ways can I arrange them? I can either make it 3 and 4 or 4 and 3. And that will become 2 different ways, which we know as 2 factorial. So for higher values, if you see me write 10 factorial, it means how many ways can you arrange 10 different items? And the answer your calculator will give you will be as follows. It will be 10, then you keep reducing to 1, multiplied by 9, multiplied by 8, multiplied by 7, multiplied by 6, multiplied by 5, or you keep going till you get to 1, 3, 2, and then 1. So this is the meaning of 10 factorial. So that is what I've been used to write the binomial formula. In the binomial formula, the first numerator you have here is n factorial divided by n minus x factorial multiplied by x factorial. And then P is the probability of success raised to the power x times Q, which is the probability of failure, raised to the power n minus x. So this is the formula we will always use when we want our binomial distribution. And I have defined the symbols for you again here. Q, probability of failure. P, probability of success. X, number of successes, which is the same as the random variable. And then finally, you have n as the number of trials or the number of experiments that you carry out. So let's learn how to use this formula. Let's learn how to use the binomial distribution formula. Now, example 1 says 40% of all voters support party A. 40% of all voters support party A. If a random sample of 10 voters is pooled, what is the probability that exactly 5 of them support the party? I read the question again. 40% of all voters support party A. If a random sample of 10 voters is pooled, what is the probability that exactly 5 of them support the party? Once you see a probability, it means we need to measure a chance. So if 40% are supporting party A, then it means that 60% are not supporting party A by implication. So that's the first thing you try and take note of. That if 40% are supporting party A, so this is support, then it means that 60% we say do not support. So these are the two possibilities that we are seeing. And once you see any scenario that is giving you an idea that there are two outcomes or two possibilities, then the word binomial should come into your thinking. Two possibilities, support and do not support. So in binomial, we represent this one by lowercase p, probability of success. So p is 40%. 40% is the same as 40 divided by 100. And finally, P will give you 0.4. So we put that one down. Now, what about 60% do not support? So that is probability of failure, which is represented by a lowercase of q. 60% is also the same as 60 divided by 100. And this, your calculator will give you 0.6. Hence, we can say that our Q in the question is 0.6. Now, if you remember the way we started, we said for binomial, there are 4 things you will find. You will find the P, which we have found. You will find the Q, which we have found. So we are left with X to find and then N to find. Once we get these 4, we can use the formula. Let's go back to the question and read again. So now we have our P 0.4, our Q 0.6. It says if a random sample of 10 voters is pooled, so the 10 voters are representing the number of people, that is N. So N is also 10. What about the last one, X? How do we get X? Then we continue reading. It says, what is the probability that exactly 5 of them support the party? Exactly 5. So the 5 you are seeing here is the X. Our X, which is the number of successes, is 5. And so we have all the 4 variables now. We have X to be 5. We have Q to be 0.6. We have P to be 0.4. We have N to be 10. So we can do this calculation. I wish at this point you had your calculator with you, so we all learn how to do this calculation. So those of you who have your calculators, you can pick them up and then we work through together. This is the formula you see on your formula sheet for the binomial probability we are finding. We are just fixing the numbers we have. To recall, the P was 0.4, the Q we had 0.6, N we had 10, and then X is 5. So we are doing substitution in the formula. It means that probability P of X is 5, out of N number, which is 10, is equal to N factorial. N is 10, so 10 factorial divided by N minus X. So that would be 10 minus 5. Okay. There's no factorial. There's no multiplication sign here, but you have to bring a multiplication sign like this. X factorial, so that is 5 factorial. Multiplied by, then we come to the P. P is 0.4. So you have 0.4 raised to the power X. X is 5, so raised to the power 5 this way. Multiplied by Q, 0.6 raised to the power N minus X, 10 minus 5. Okay. So you take your time and then you input this in your calculator. And if you don't do it step by step, you are likely to have your answer wrong if you haven't mastered your calculator. So those of you who cannot do it, probably next week when we meet face to face, let me know and then I can walk you through this. But those who can do, let's use your calculator to do something. So just press 10 factorial on your calculator and let me hear you out. The answer you had. Just press 10 factorial is on your calculator. You have to press shift and then pick it up.
Yeah,
What did you get?
3,628,800.
Very good. So 3,628,800. Very good. Divided by, so we are going gradual. 5 factorial times 5 factorial times, do this one too for me, 0.4 raised to the power 5. Let's see what you get. I'm sure you'll be having something like 0.01024 multiplied by, then you do this one to 0.6 raised to the power 5. 10 minus 5 will give you 5 raised to the power 5. I'm sure you also get
0.0777.
Okay, so let's continue. So I'm sure you get 0.07776. I want somebody to confirm my figures before we continue. Did you get that?
Yes, sir.
Very good. So those of you who are not seeing what we are doing in terms of the calculation, please don't worry. I can show you on your calculator next week. So let's do the down one and then we put all together. We have 3, 6, 2, 8, 800 divided by, so let's now do 5 factorial times 5 factorial. 5 factorial multiplied by 5 factorial. I'm sure if you do it well, you have
14,400.
Very good. Now that we have released all of them, we can now multiply all of them together and divide by what you are seeing. Let's see the answer we get at the end of the day. So at this point, I'm sure a lot of you can do this computation.
Okay, so the 0.0124 times 0.0776.
Yes, so do we want to do everything? Do everything at your end for me.
Okay.
So those who are doing, you end up getting some plenty numbers, but we just want it to 3 decimal places. And you end up getting 0.201.
201, yes.
Very good. So it has been confirmed. We in business, we are not comfortable with decimal numbers. We always want our staffs in percentage. So anytime you get a probability answer in decimals, you can change it to percentage. So if we want to change this one to percentage, we'll just multiply it by 100%. Anytime you want to change a decimal to percentage, just multiply it by 100%. And if you do that, you have 20.1%. So our answer will be 20.1% chance. Okay, that is a small chance. 20%, 20.1% chance. So what it means is that the people who will support party A, if 10 voters are voting and you pick 5 of them, the chances, that's the probability, the chances that they will vote for party A, our answer says that the chances is 20.1%. That's a small chance. Okay, that's a small chance. 20.1%. And that is how to use the probability distribution formula. Any question before I move to the next? Any question about what we have done so far before I move to the next thing I want to do? All right, so I presume you are following small, and I'm sure when you watch the video again, you will understand the steps we are taking. Right from the time we started the course, I told you there are some 3 things we are doing. First of all, we find the shape of a distribution. We find the shape of a distribution. Okay. After finding the shape, we find the center of the shape. After finding the center of the shape, then we go find the spread. So to take you back one more time, if you remember when we started with the statistics or the frequency, when we started with the frequency distribution, you remember we were able to find the shape of the distribution. And then the shape of the distribution, we had leptochaetic shape. We also found mesochaetic, and then platychaetic. That was the shape of the frequency distribution, which we did together. After that, we found the center. And the center, we called it the arithmetic mean. And the formula we used, if you remember, was x bar equals sigma fx over sigma f. And then we went ahead to find the spread. And the spread was the standard deviation we learned. And to remind you of the formula, we said standard deviation S is equal to square root of sigma fx squared divided by sigma f minus sigma fx over sigma f all squared. And that was how come we were done with the shape of the frequency, the center of the frequency, and the spread of the frequency. Then from there, when we started the probability, we also looked at the shape by finding what we call the PDF. The PDF. And after getting the PDF, we found the center of the PDF, which we represented as expectation of x, EX, is equal to summation I starting from the first item to the last item, x times its corresponding probability, which we used last week. Then after that, we found the spread when we were finding the variance. Uppercase sigma squared is equal to summation I starting from the first item to n, the last item, x squared times its corresponding probabilities minus mu squared. So in all the cases, immediately we finish finding the shape, we go ahead and find the center, we find the spread. And that's the same thing we want to do to this binomial distribution. If this is giving us the shape, what will be its center? What will be its spread from the center? That's the next thing we want to do. So these are the formulas that are used to find the center and the spread of binomial distribution or chances. So the mean or the center is given as this big symbol mu, M-U-O. Mu equals NP. It means that anytime you want to find the center of a binomial distribution, just look for your N in the question. Look for your P in the question and then multiply them. With that, you are done. Then for the spread, which is also called the standard deviation in this case, it also says that just pick your uppercase sigma, find the square root of these three symbols you are seeing here in the question. Once you get your N, once you get your P, once you get your Q, it means that you are ready to find your spread. So these two are simple formulas that helps you in binomial to find the center of the binomial and to find the spread of the binomial. Let's learn how to apply it. So in the same question we did, in the same party question we did, these were the figures we had. We had n to be 10. We had p to be 0.4. We had q to be 0.6. So when you are asked to find the mean, which is the center, the mean of the binomial distribution, all you do is pick this mean formula. This is how to find the center. So mu equals NP. You pick your N, which is 10. You pick your P, which is 0.4. You multiply the two, and then you have your answer. So the answer here is 4. Just N multiplied by P. What about the spread? The spread is sigma, uppercase sigma equals square root of NPQ. The N is 10, the P is 0.4, the Q is 0.6. You fix it and then you have your answer here, 1.549. So in a typical question, like you are seeing in this, you can be asked first of all to find the probability showing the shape as your A question And then B, we can be asked to find the center, which is the mean. And then C, we can be asked to find the spread, which is the standard deviation. And I'm sure by now you are following the trend of how the questions can be. You find the main thing, you find the center, you find the spread, and then you are done. So this is the end of the binomial distribution. In other words, the three formulas you are supposed to know for the binomial distribution are as follows. For the PDF or the shape, you need to know this formula so you can pick it in the formula sheet. Pxn is equal to n factorial divided by n minus x factorial x factorial p to the power x q to the power n minus x. So this will be for the shape. Then secondly, 2, you need to know mu equals np because this will be for the center. And then 3, you need to know uppercase sigma equals square root of npq because this will be for the spread or the standard deviation. And these are the 3 formulas that will be given for binomial calculations. Now we are done with binomial distribution. We want to now look at the next one called the Poisson distribution. The Poisson distribution. The binomial, if you have even forgotten about all that we have done, don't forget about this, that binomial deals with only 2 possibilities. It deals with only 2 possibilities. And these 2 possibilities are either you have a success or you have a failure. These are the 2 possibilities. But let's look at Poisson. Poisson is not about 2 possibilities. Poisson is about something else. Let's look at the characteristics of the Poisson distribution. Now, the Poisson distribution depends on 2 things: time or space. Poisson occurs within time or space. Now we say certain number of events will only occur over specific interval of either time or space, and not 2 possibilities like binomial. Poisson deals with time or space. Let's look at some examples that can make us understand the definition of the Poisson distribution, which we see every day in our lives. Number 1, look at this one. Number of customers per hour. Is it possible to know the number of customers per hour who will come and buy something in your shop? You may not know. So you will depend on chances, probabilities, chances. What are the chances that 100 people will come to your shop within 1 hour? You don't know. How will this occur? This will occur in time. This will occur in time. So for Poisson, the occurrences are within time or space. 2, as an employer, how do you know the number of strikes your workers will go in a given period? You will not know. As a government, how will you know the number of strikes the public servants will undertake within a given period? You don't know. It will either be within time or space, and not two possibilities. 3, the number of accidents per month. How do you know this? The number of accidents per month. No, you cannot use binomial. It is Poisson, because Poisson deals with events that occur within time and space. And then 4, I repeat like I did in 1. All cases of arrivals at supermarkets or filling stations. Do you know the number of cars that will come to your filling station in a particular day? No. Does it mean you shouldn't plan for the cars? No. So you have to take the risk, or what we call the chances. And so if you are stocking fuel, whether gasoline or diesel, you have to stock in such a way that you will not do over stocking or under stocking. You have to use probability to be able to stock enough. So all these are chances we need to measure. And then once you measure them, you calculate your risk very well. Okay. This is why we need to know how Poisson works in terms of percentage. Now, the distribution of Poisson is also controlled by another new formula we are learning today, which will also be given to you in exam. So don't memorize it or write it somewhere and bring it. Just know how it is used and how it appears. So Poisson has this probability or chances formula, which is written as probability of the random variable x is equal to this symbol here is a Greek symbol called lambda. Lambda. Okay. So lambda raised to the power x. And this e here is the exponent on your calculator. E raised to the power negative lambda divided by x factorial. So you now understand the symbol factorial. Okay. This is the formula for the probability distribution. The x, as usual, is the occurrences or the random variable. And then the lambda will come from experience. Or something that you know. And so if you look at the formula, There are basically two things you just look out for in your question. You look out for your lambda, and then you look out for the x. Once you fix them, you have your probability. The moment you hear probability, please do remember we are talking about chances. Chances. So it's like we are just trying to calculate our chances on certain events that may occur later. As usual, once we know the shape of the chance, we must know the center. And then we must also know the spread. Let's look at how to calculate the center of the probability distribution, which is the same as the mean. And then let's look at how to calculate the spread, which is the same as the standard deviation. All right. This looks very simple. In fact, for the Poisson, the formula for the mean is the same as the formula for the standard deviation. So the formula for the mean in Poisson distribution is mu is equal to lambda. Mu is equal to lambda. And then the standard deviation is also uppercase sigma squared is equal to lambda. So look at it. All equals lambda. So once you find the lambda in the question, the same lambda is the center or the mean. And the same lambda is also representing the standard deviation. And that is the beauty of the Poisson distribution formula. The mean and the standard deviation are the same. The mean and the standard deviation are the same. Or the variance and the mean are the same. Let's pick an example to understand how this formula is used. Now the question reads, example 2 for the day. It says, if a bank receives an average means mean. Okay. If a bank receives an average of lambda equals 4 bad checks per week, what is the probability that it will receive 3 bad checks next week? If a bank receives an average of lambda equals 4 bad checks per week, what is the probability that it will receive 3 bad checks next week? So this is planning for next week. The bank has seen that over time, every week, they are receiving 4 bad checks. The checks were not spelled well. Forgive my English language. It's supposed to be CHEQUES. This is the correct spelling. So the bank receives 4 bad checks every week. Now the bank is about to enter into next week and is trying to measure the chances. Probability is about chances. It's trying to measure the chances that the following week the bank will receive 3 out of 3. 3, not 4, but rather 3. In other words, they want to calculate their chance to see whether the 4 bad checks they know every week will reduce to 3. They want to see the chances that it will reduce to 3. How do you know that this problem is not binomial, but it is Poisson? How do you know? The moment you see the lambda, it tells you this is a Poisson. If they don't even bring the lambda and they say if a bank receives an average of 4 bad checks per week, an average of 4 bad checks a week, it means that it is something they know. So that one becomes your lambda. Lambda is coming from experience. Okay. So our lambda here is 4. Then how do you know the x? The x is the random variable. So the guess is, what is the chance of receiving 3 bad checks next week? Your random variable becomes 3. 3 bad, we are just guessing. We don't know. So once you are guessing, then you are guessing with a random variable. Okay. You are guessing with a random variable. Hence, our x is 3. So quickly, we pick the formula we learned today and then we fix it. The formula was probability of a random variable x is equal to lambda raised to the power random variable x multiplied by the exponential on your calculator raised to the power negative lambda, all divided by x factorial. We'll end up fixing them. Lambda is 4, so we have 4 raised to the power 3 multiplied by this e is on your calculator. So when you press it, this number you are seeing here will appear. This is on your calculator. There's an e there. When you press the e, this will come. So you have 2.71828 raised to the power negative 4, all divided by 3 factorial. When you press all this on your calculator, you end up getting 0.1954. And I said earlier on that we business people, we are not comfortable with decimal places like this. This is for those doing pure science. So we always want to convert our probabilities to percentages. In that sense, you multiply this one by 100%. And if you do that, your final answer will be 19.5. One decimal place, 19.5% as our answer. Okay. So meaning that our chances we want to measure here, that what is the probability that the bank will receive 3 bad checks next week? Our chance or chances is 19.5%. which is a low chance or probability. So if we don't receive 3 bad checks, we will not be surprised because the chances of receiving 3 bad checks next week is 19.5%, which is a lower percentage in terms of measuring our chances. If you are asked to find the mean, let's say there's a second question and you're asked to find the mean of the distribution, and then another question, you're asked to find the variance or standard deviation. The formulas are simple. Mean, we said mu is equal to lambda. Lambda has already been given in the question to before, so therefore the mean or the center is 4. You don't calculate anything, you just replace the lambda with the 4 in the question. And then the variance, the same thing. Variance is the same lambda. So therefore, our spread will also be 4 next week. So this is how to use the Poisson probability distribution formula. Any question about this calculation we have gone through? Any question, any contribution? Any question? All right, so
Sir,
yes.
yes, looking at the latter part of the calculation, it was multiplied by 100%.
Yes.
Where from the percentage? Because I'm trying to get.
Yes, so I was saying that in business, when you have decimals, you are not able to explain the decimal answers well. So you need to change it to percentage. And in changing the decimals to percentage, you multiply it by 100% because 100% is the same as 100 divided by 100. 100 will cancel itself 1. It will cancel itself 1. 1 divided by 1 is 1. So you haven't done anything. You come back to your decimal. Did you get what I did?
Yes, sir.
Yes. So anytime you get a probability answer in decimal, let me put it that way. Anytime you get a probability answer in decimal, multiply it by 100% and change it into percentage so that you can see the picture well. That's a good question. Also. Any other question? All right, so any other person I'm waiting for? All right, so once there's no question, let's try and solve a question that looks like a combination of what we know in probability and then let me see whether you can understand the way to apply the formulas when you get a story problem to solve. You have to be very versatile with your calculator, like I was doing with one of you. You have to know how to use the calculator when it comes to the raised to the power and the exponential and the rest. So this is a typical examination question. And probably once you understand what you are doing, you can be able to solve such problems within some few minutes if you know what you are doing. What actually we do in quantitative methods in terms of solving problems are that you need to follow 3 steps. You need to follow 3 steps. Now, the first step is called identify. The second step is called compute. And then the third step is called interpret or explain your answer. Okay. So identify means that which formula are you going to use? You ask yourself after reading the question, which formula are you going to use? Once you're able to see the formula you will use, because you'll be given a formula sheet. So you have to go through the formula sheet. And then after reading the question, know which formula you use. Once you get the formula, compute means that come and substitute all the values you have seen in the question into the formula and then work it out. Once you work it out, you get an answer. And then what you do, come and explain your answer. That's the meaning of the interpretation. You explain your answer. And I think we have demonstrated that today by the 2 examples we did. The first example was about some support for a certain party. We ended up getting 20.1%. And we explained it that if 5 people out of the 10 are going to support party A, it will just be 20.1% out of the 5. That's the explanation we gave. And then after that, we did this check example that the bank is receiving 4 bad checks every week and wanted to measure the chance that the following week, are they going to receive 3 bad checks? And the percentage we had was 19.5%, which is a low or a lower chance. And we explained. Okay, so for every problem, you need to learn how to, first of all, identify the formula you will use. After identifying the formula, then you compute or you solve the formula with the data you have in the question. And then after that, you explain your answer. Let's apply that to this question. I'm just showing you the process, the 3-way process that can always help you to analyze your question and to solve them well and to give a better interpretation. So let's look at this question and see how we can go through the three processes. It says, GTUC, an organization, has discovered that 20% of its BBA students withdraw without completing the elements of mathematics course at level 200. Assume that 20 BBA students registered for this course for the 2014-2015 academic year. I take it again. Assume that 20 BBA students registered for this course for the 2014-2015 academic year. If they did, A, what is the probability that 2 or fewer will withdraw? B, what is the probability that exactly 4 will withdraw? C, what is the probability that more than 3 will withdraw? And then D, determine the expected number of withdrawals. Okay. So you don't have too much information, but there's a lot to do when you have a question like this. This is a university that is having Bachelor of Business Administration students, and the question is giving information that there's a particular course called Elements of Mathematics. And then it's saying that the school has discovered that almost every time 20% of the students withdraw without completing the course. This particular course, 20% withdraw without completing the course. So if 20% withdraw without completing the course, it means that 80% do not withdraw and they complete the course. So that is the extension we can deduce from this one. That when 20% of the students withdraw, you'll be left with 80%. So this is where your mind should really work on what we have done today. Is this thing operating by 2 possibilities? Is it talking about 2 possibilities? Or is it working within time and space? That's the question you ask yourself. Has it mentioned time and space? Is it mentioning possibilities? That is very key in unlocking this question. So this is about students withdrawing and then staying. Okay, so it means we have 2 possibilities. So it means that if you take the probability of those withdrawing, RP is 20%. Those who are not withdrawing, Q is 80%. So Q, 80% is the same as 80 divided by 100, and this becomes 0.8. Then P, 20% is 20 over 100, and this becomes 0.2. So the P and the Q has given you an idea of which formula we need to go use to solve this problem. And that is how to start. And so you pick your binomial probability formula, P x taken from n is equal to n factorial divided by n minus x factorial, x factorial, multiplied by probability p to the power x q to the power n minus x. This will be in the formula sheet. So you go pick this formula which you have identified. So we are done with the step. We have identified it. We are now at stage 2. We need to compute this. How do we do that? We need 4 variables. We need P. We need Q. We need N. We need X. Fortunately, we have P. We have Q. All we need to look for is N and X. And then we'll be good to go. So upon further reading, we realize that it says that assume that 20 BBA students registered. So this is representing number of students. Assuming that 20 BBA students registered. So N is 20. We have our P, 0.2. We have the Q to be 0.8. We now know N to be 20. X is a random variable. And once X is a random variable, X will be changing. It cannot be a constant number. X will be changing. That's the meaning of random. Okay. So let's see where we will position X. It says, what is the probability that 2 or fewer? We need to learn how to write this. What is the probability that 2 or fewer? 2 or fewer will withdraw. This is how we can write this symbolically, which you are also learning today. Probability that 2 or fewer. Okay, so probability of random variable X, 2 or fewer. So X should be less than or equal to 2. This is what they want you to find. 2 or fewer. Fewer means less. So what's the probability that 2 will withdraw, or 1 will withdraw, or nobody will withdraw? That is what this one means. 2 or fewer. Probability of X less or equal to 2. 2 or fewer. So it means that we need to calculate probability of X equals 0 plus probability of x equals 1 plus probability of x equals 2. So this is what we need to do. For the first one, this one, probability of x less or equal to 2. So let me write it beside it before I pick the next one. Probability of nobody withdrawing plus probability of one person withdrawing plus probability of two people withdrawing. That is what we will do for the first one. Now the second one, it says, what is the probability that exactly 4 will withdraw? So what is the probability that exactly 4 means x equals 4? We should find probability of x equals 4. Then C, what is the probability that more than 3 will withdraw? More than 3 will withdraw. So it means that we should find probability of x is greater than 3. It says more than 3. Greater than 3. Now this one, in terms of probability, we can't go more than 3. We can't keep on going. So what we are going to do to this one is that you can rewrite this one the same way as, I hope you haven't forgotten that total probability in this world, total probability is equal to 1. I'm sure you haven't forgotten about this. Okay. So it means that probability of x greater than 3 is the same as 1 minus probability of x equals 3. Then the last one, determine the expected number of withdrawals. Expected number, the word expected number means find the mean. Find the mean. And we have done this today. How do you find the mean of binomial? Mean is represented by mu. The formula is, we are going to use this formula, mu is equal to NP. That will give us the results. So this is how we have analyzed the questions. And then let's try and then use our computation to see the results we will have. So let's do it together. Now this is the formula we are using. And so our writing is going to be plenty and our calculation is going to be plenty. So I hope your calculator or your calculators are with you. Let's look at the first one. We are now calculating probability of x equals 0, probability of x equals 1, probability of x equals 2. What it means is that wherever we see x, we put 0 for the first one. And then for the second one, wherever we see x, we'll fix 1. And then for the third one, wherever we see x, we'll fix 2. So let's do it together now. Probability of x equals 0. So we have P like this. 0 out of n is 20. It's equal to 20 factorial divided by 20 minus x is 0. So 0 factorial multiplied by 0 factorial. P from the question was 0.2. Raised to the power x, x is 0. Let me write that one well. X is 0. Multiplied by Q is 0.8 to the power 20 minus 0. So this is the first one plus the second one is probability of x equals 1. Wherever we see x, we put 1 there. So we have probability of 1 and 20 is equal to 20 factorial divided by 20 minus 1 factorial multiplied by 1 factorial multiplied by 0.2 raised to the power 1 multiplied by 0.8 to the power 20 minus 1 plus the third one. I don't have space, so I have to write it up here, and then we can take our time and solve all of them together. So let's look at the third one. The third one will be probability of x equals 2. So this will be probability 2, 20. Same 20 factorial divided by 20 minus 2 factorial times 2 factorial times 0.2 to the power 2 times 0.8 to the power 20 minus 2. So those with calculators, please help me. Let's get the results for these ones. Anybody calculating for us?
Yes, sir.
Yes, so have you done the first one? So I'm waiting for you.
20 factorial.
No, I
Or
mean
you
I
want the
want
whole
you to
thing?
do I want you to do all, like
Yeah,
the
yeah.
first one.
I'm seeing exponent 18. So I wanted to know how
Pardon me.
exponent 18 for the
Pardon me.
20. I was saying that
Uh-huh.
the 20 factorial,
Yes.
I'm getting like 2 point something exponent 18. I wanted to
Yes.
know how that one is going to, or 10 to the power 18.
Oh, in fact, that one, this one should be simple. Oh. I think you saw it because it will cancel. It will be 20 factorial divided by 20 factorial. Haven't you seen it?
Okay, yeah, yeah.
So you don't struggle there. As for this side, it will cancel. So all you are doing is this other side, 0.2 to the power 0. Any number raised to the power 0 is 1. So the actual calculation you are doing is 0.8 raised to the power 20. That's what I'm waiting for.
Okay.
I hope it is not only one person who is doing the calculation for us. I expect all of you to be having your calculator by your side. And then if you have issues, we can help you. So those doing it, I said this first one, 20 minus 0 will be 20 factorial. So you see that this 20 factorial will cancel this 20 factorial. So you don't do any calculation here. It's only this side. 0.2 to the power 0 is 1. So the actual calculation you are doing is this one, 0.8 raised to the power 20. That's what you need to press on your calculator. And by now you should be able to do this.
Yes, 0.011
Okay,
5
zero. No, give me
0.012.
three decimal places. Three decimal places.
Okay, 0.012.
0.012. Very good. So we are done with this one. Let's now go to x equals 1. So x equals 1 to watch this side. It will be 20 factorial divided by 19 factorial. When you do it on your calculator, you get a small value. Try it and see. 20 factorial divided by 19 factorial. I think the answer will be 20 or so.
I had 20.
Very good. So then multiply it by the others. It's very simple. It's not too difficult. So 20 times 0.2, what will you get?
Four.
Yes, so multiply the 4 by this one, 0.8 raised to the power 19. I don't know why you are struggling with the calculator. So multiply the 4, just press 0.8 raised to the power 19. The results you get multiply by 4. Let's see what you have.
I have 0. 0.057.
Okay, 0.
0.058.
Very good. 7.
It's when
Okay,
I convert the next one, then it will be 8.
that's fine. 0.058. Very good. You've done well. Then let's do the last one. You see, it's easy. Last one, 20 factorial like this, divided by 20 minus 2 is 18. So 18 factorial times 2 factorial multiplied by 0.2 squared multiplied by 0.8 raised to the power 18. So you can do this one to 20 factorial divided by 18 factorial times 2 factorial. Whatever you get, you multiply by 0.2 squared, and then you multiply your answer by 0.18, 0.8 to the power 18. Let's see what you have. I want you to learn how to use the calculator. Other than that, I'll do it at my end here, write the answers, and then when you are learning alone, you may find it difficult to understand the answers I'll be writing. That is why
I'm
I'm
getting
making
something like 0.
What do you get?
0.5
0.5
547 or 0.548.
548. Okay, let me let another person confirm. Then we use it. 0.548. Who else? I just want a confirmation.
Yeah, I'm getting 0.1368.
Okay, so another person had 0.137.
137.
1 point. Okay, so let me confirm. Let me also do it, and we'll be sure
Okay.
of the answer. Yes, I think your answer is correct. 0.137. The first one is wrong. The second one is correct. 0.137. So please, I want the class to, those who can use the calculator, see Vivian.
Yes.
I think it was Vivian. It was Vivian who gave me the
Yes.
answer. See
Okay, go
Vivian.
back.
Vivian will show you how to use the calculator. So now let's put all together now to find the actual probability the question was looking for. Probability of x lower than or equal to 2. We are putting all together now. So 0.12 plus 0.058 plus 0.137 Let's put them together now. 0.012 plus 0.058 plus 0.137. If you
That's
put all together, you have 0.207. And this is our first answer. That was why I told you that this is an examination-like question. See how we have struggled to get our first answer. You need to go through all this step, do all this calculation, and get the final answer. And you are being asked to interpret.
5 hours.
I think Owusu or somebody was asking me, why should we change this one to percentage? You change it to percentage so that you can be able to explain your answer. So in changing this one to percentage, you multiply by 100%. And so your final answer becomes 20.7%. What does it mean? Interpretation. It
Children.
means that the chances that two
Yes.
or fewer people will withdraw is 20%. That is what it means. It means that the chances that two or fewer people will withdraw is 20.7%, which is a low chance. So it means that two or fewer people may not withdraw because the chances are low. That's the first one we have done. The second one says that once I'm done with the second one, because of time, our time is up. You may try your hands on the C and D before we meet next week. But let me do the second one. The first one was longer. The second one is very short. What is the probability that exactly four will withdraw? They want you to find X equals 4. So you go back to the formula. Wherever you see X this time, you just push 4 there and then you are done. So let's look at the answer we'll get for that. We are using the same formula we have written here. This time we are finding X equals 4. And so those who are still not comfortable with how the expressions are calculated, I think Vivian has gotten it right. So you can see Vivian and then she will take you through step by step how to input them in the calculator. We are doing probability of X equals 4 for our B part. So this is the formula. Means probability of 4, X is now 4 out of 20 is equal to 20 factorial divided by 20 minus 4 factorial times 4 factorial times, then we come to the top part, 0.2 to the power 4 times 0.8 to the power 20 minus 4. So let's do this one and see the answer for this, and then we can close the class for today. We have about 5 minutes to end our session. So let's do it again. Let's all try it again. 20 factorial divided by 20 minus 4 factorial. Anyhow you want to do it. Make sure you are arranging them in order. So you should be getting somewhere around 0.218. 0.218. You multiply it by 100%, and then your answer becomes 21.8%. So I'm waiting for the answer you have, and then we can close.
Hello, sir.
Yes, Philip.
Yes, sir. Can we do the 20 factorial over the 20 minus 4? Let me see the figure I'm going to get, because I think that's where my challenge is.
Okay. All right. So let's do that in closing. I have 3 minutes. Let me show you how to do this on your calculator. I'm sure you guys have not mastered your calculator. That is why you are struggling. Now, 20 factorial divided by 20 minus 4 factorial times 4 factorial. Now, which calculator are you using?
Scientific.
Very good. So go to the left-hand side. You see a template like this. It's like they have shaded one side. Have you seen this thing? Like some box, one is shaded. Have you seen it?
Yes, sir.
So pick it.
Okay.
When you pick it, what has come? After pressing it, what has come? Are you seeing two boxes?
No.
Philip, I can't hear you.
Yes, sir.
Have you seen two boxes?
Yes, sir.
Aha. So the first box, type 20 factorial into it.
Okay.
And then drop down.
Okay.
Then 20 minus 4 is 16. So type 16 factorial.
Okay.
Then multiplied by 4 factorial.
Yes, sir.
Then bring the cursor to the middle and press equal to.
Okay.
What number came?
2790720.
Okay, exactly. So that is how to use the calculator to be doing the factorial.
Yes, okay.
You
Then
get
when you're
it
done
now?
with that, you multiply it what you're going to get for the
With
0.
the rest, yes. Exactly. So next week when you meet face to face, Vivian and Philip, you have to help your other colleagues who do not know how to use the calculator very well. So on that note, we'll end the class today. Our time is up. We can't exceed our time. Thank you for your usual participation. God willing, we'll finish the semester face to face in the school on campus next week. I wish you a good week. The meeting is over.
Thank you, sir. Same to you.